What made it so powerful?
It's like the aftermath of an atomic bomb.
Could it have been predicted?
It's a huge catastrophe, the most widespread devastation we've seen from a natural disaster for centuries.
Could it happen again? It's now 29 days since the tsunami struck, and the world is still struggling to come to terms with the enormity of the disaster. But how and why did it happen? Using eyewitness testimony and scientific analysis, this film details a minute-by-minute account of the unfolding disaster as it tracks the tsunami on its destructive path across the Indian Ocean. It's the early morning of the 26th of December, 2004. Southeast Asia awakes to the morning after Christmas Day. In Sumatra, fishermen are already on the water. In Sri Lanka, 1,500 people begin their train journey from Colombo to Galle. Among them, British tourist Shenth Ravindra.
I left my dad and his family in Colombo on Boxing Day because I was going to Hikkaduwa to do some scuba diving around the coral sanctuary. My dad was very keen for me to actually catch the train to Hikkaduwa because of the beautiful scenery that I would encounter on the way down.
In Thailand, Tom Travers and Richard Anthony open up their beachfront restaurant.
I went down, put some laundry in, which we came back, ordered some breakfast through. Yeah, it was just another normal day, basically.
And in Hawaii, scientists at the Pacific Tsunami Warning Center test their systems.
Wyoming, Colorado.
All these people are totally unaware they are about to be caught up in one of the worst natural disasters ever. Shortly after dawn, and entirely without warning, a huge earthquake rips across the ocean floor. The Earth's crust is divided into giant rafts of rock called tectonic plates. The plates are always on the move, driven by convecting heat from within the planet. Where they collide, massive forces are at work. The plate boundaries are marked by active earthquake zones. When they grind past each other, an earthquake occurs. Under the ocean off Sumatra, the Indo-Australian plate is grinding underneath the Eurasian plate in a process called subduction. It's been doing this for 20 million years. On December the 26th, something snapped. Phil Cummins of Geoscience Australia has been studying earthquakes in the region for over 15 years.
The Indo-Australian plate is what's called subducting beneath Indonesia. It's sliding beneath the plate that Indonesia is situated on. That interface has what's called stick-slip frictional properties, and that means it drags the upper plate down with it. And it pulls it down and deforms the upper plate, builds up strain energy. Eventually the stress on that contact exceeds the strength of the contact, and the upper plate snaps back into position.
The earthquake's epicenter is located 155 miles to the southwest of Aceh province.
The rupture, the fault that actually tore in the Earth's crust is about 1,200 kilometers long. So it goes all the way up from western Sumatra, right the way up through the Nicobar and Andaman Islands.
The continental plate shoved out over the oceanic plate by about 10 to 20 meters. Most of the motion was horizontal, but some was vertical because the plate boundary, the fault, is inclined.
Most of the energy travels perpendicular to the strike of the subduction zone. So it more or less went east-west, towards Sri Lanka to the west and towards Thailand to the east.
Minutes later, this seismogram appears over 8,000 miles away in California. It shows how the earthquake continued for over 4 minutes. Later analysis confirmed that it measured 9.0 on the logarithmic magnitude scale, making it one of the most violent on record.
For every unit you increase in magnitude, you go up about a factor of 30 in the radiated energy. So it would take 30 magnitude 8 earthquakes to match the energy of a magnitude 9. So the Sumatra earthquake, which was magnitude 9, is about 1,000 times the energy of the magnitude 7 Kobe earthquake.
Banda Aceh feels the full force of the earthquake as buildings collapse, 20 minutes before the water arrives. It's more powerful than all the world's earthquakes over the past 5 years put together. Halfway across the world in Hawaii, barely a minute after the earthquake, computers at the Pacific Tsunami Warning Center spring into life as they pick up on seismic signals. Any earthquake over magnitude 6 prompts an automatic paging sequence to the scientists on duty, alerting them in an instant.
I just fed my cats. I was lying down for a kind of a nap. It had been 3 or 4 days I've been on duty already. I was on the verge of falling asleep when my pager went off. I looked at the pager very briefly. I could tell from the message that I was dealing with something probably larger than a 6, and I was here within about a minute. And Stu Weinstein was already looking at them.
I noticed that the trace of this seismic area was very full. It appeared as kind of just like one thick line going across the screen, and that told me that it was a substantial earthquake.
The warning center relies on data from a network of seismic stations to detect earthquakes. But their system of coastal tide gauges and deep ocean pressure sensors triggered by tsunamis are located only in the Pacific. Thanks to this system, the center has successfully warned Pacific coastlines against a series of killer waves for over 50 years and saved countless lives. But in the Indian Ocean, there is no such system. In the first few minutes after the earthquake off Sumatra, data from seismic stations has already alerted Weinstein and Hershorn to its location and size, enough to cause them grave concern.
I then estimated the magnitude at a magnitude 8. Our response was, wow, that's a fairly large event. And we issued our first official product, which was a Tsunami Information Bulletin.
The bulletin informs Pacific coastlines of the earthquake. But with no network of tsunami sensors in the Indian Ocean, Weinstein and Hershorn have no way of knowing if a tsunami has been triggered there.
The seismic analysis can only take you so far. We also looked at what water level information might be available, and because this was the wrong ocean, the answer was none.
We had no tide gauges, and so at this point we had no evidence that there was any waves generated.
And this was a tremendous, crippling, frustrating experience, because without water level gauges, we don't know if there's been a tsunami.
We were, unfortunately, flying blind.
As they watched events unfold, their frustration would turn to despair. When an earthquake occurs under the ocean, its energy can dissipate as shock waves through the crust, or as tsunamis through the ocean.
Whether that shock wave turns into a tsunami, into a water wave, depends on where in the Earth's crust the earthquake takes place. In this case, it took place very near to the surface, the seabed.
This earthquake was only about 30 kilometers deep, which is very, very shallow. If it had been 200, 300 kilometers down, it would not have generated a tsunami.
Seconds after the earthquake, the energy it releases, the equivalent of 23,000 Hiroshima-sized atomic bombs, is instantly transferred to the water column above the ocean floor in a process called tsunami initiation. As the seafloor lifts, it displaces billions of tons of water above it. Geophysicist Tom Heaton of Caltech is an expert on earthquakes.
As a result of the earthquake, part of the ocean floor has been uplifted and part has been dropped down along the fault surface. Because the seafloor changes, so does the water column above the seafloor. So some parts go up here, some parts go down.
Seconds later, the tsunami undergoes its first transformation as the displaced water column splits.
The uplifted area basically collapses and the water rushes away from the uplifted area, creating a tsunami wave that's traveling radially away from the uplifted area. The tsunami wave's now speeding off to some distant shore at 1,000 kilometers per hour.
The main pulse can cover the ocean quite rapidly, which means that in the initial few minutes, the northwest part of Sumatra would have been hit.
Ten minutes after the earthquake. In Sumatra, thousands begin their day, unaware of the approaching wave as it charges towards them at over 600 miles an hour. In the open ocean, tsunamis are virtually undetectable. This simulation, run by oceanographer Simon Boxall, demonstrates how a boat in deep water is only slightly affected. In the open ocean, fishermen may not even notice a tsunami passing underneath their boat. But as it nears land, it rears up into a monster, growing by a process of amplification.
As the wave approaches the land, the front of the wave slows down. It slows down to 400, 300, 200 miles an hour. The back of the wave is still going at 500 miles an hour, and the back of the wave catches up with the front, and you get this big build-up of water.
The amplifying wave can have a curious side effect. Before it hits land, it draws water from its leading edge, exposing the seabed for as much as a mile. It's a phenomenon that would lure thousands to their deaths.
One of the big problems about trying to prevent deaths due to tsunami is trying to stop people rushing down to the beach when the sea goes out. And that happened here. People went down, they saw fish flapping about on the beach, went down to pick them up.
If you see the sea start to go out, you don't stand and wash in oar, you run.
Tsunamis rarely roll towards land like a classic surfer's wave. Instead, they surge forward like an onrushing flood. The leading face builds into a wall of water. They're so deadly because the volume of water behind them is so great.
Tsunami have wavelengths, which is the distance from the crest of one wave to the next wave, of hundreds of kilometers. It will keep coming in maybe for 5 minutes or more, and it has enormous mass behind it.
People see water as being fairly soft, gentle, something fairly benign. But bear in mind that water is very heavy, and a cubic meter of water weighs a ton. So if you've got one of your kitchen units at home full of water coming towards you or falling on top of you, that's a ton of water. That's like having a car land on top of you.
The sort of waves that we've seen in the Indian Ocean tsunami of 2004 are probably able to deliver for every 1.5 meters of coastline 100,000 tons of water, which is an extraordinary figure. And that is coming into the coastline, hitting the coastline with incredible force.
And as the tsunami progresses, as it goes through the coast, it's picking up stones, it's picking up debris, like a tornado almost, and that debris, cars, people being thrown at you at 40 miles an hour, that's going to hurt, that's going to kill you.
Just 15 minutes after the earthquake, northern Sumatra is the first to experience the full impact of the tsunami.
This is what's left of the Banda Aceh cement works and the wharf area. The ship being totally trashed there. Here we've got these huge big sections of breakwater, and they've just been sheared off and thrown over here like rag dolls. And these pieces here must weigh hundreds of tons, and it just defies belief really, which kind of gives you some idea of just how awesome this thing was.
The damage sustained by this cement factory is another clear indication of how high the wave was when it hit.
Just this area we've been walking around here today is like the aftermath of an atomic bomb, is maybe worse.
But in Sumatra, the real cost is a human one. Under all this wreckage lie thousands of bodies. 3/4 of the tsunami's victims died here in Sumatra. But the Great Wave is far from finished. Just 15 minutes later, the Andaman and Nicobar Islands are also hit. Over 7,000 die or go missing.
For those who have been rescued, a refugee centre has been set up in Port Blair, the tiny capital of these islands. 1,500 were there when we visited, with more arriving all the time. Relatives search desperately for the name of a loved one on the admissions board.
45 minutes after the earthquake, scientists at the Pacific Tsunami Warning Center are still unaware of the tsunami. But they're desperately trying to analyze the earthquake.
Where the water came to, just over to our restaurant bar here, which is quite amazing. You can see here, the water only came to this depth, whereas on the next beaches, the water went to 7, 8 metres and went 1 kilometre inland. We've been blessed here, absolutely.
Nearby Kamala Beach suffered some of the worst of the damage. Not only does its shape leave it fully exposed to tsunamis, but the gentle gradient of its seabed amplifies the destruction of the wave.
The actual rate of shallowing of the seabed as you approach the coast seems to be quite important in determining the destructive capacity of the tsunami and how far it goes inland. At Kamala, it looks as if the seabed is very, very shallow over a long distance. So there's very little to stop the wave building, to stop it coming in. And the land behind there also is very low lying, so the wave's penetrated kilometres inland in those positions.
In Kamala, Tom Travers and Richard Anthony are having breakfast on the balcony of their restaurant when they see the tsunami approaching.
And probably went from about 300 metres out to the break wall here in less than a minute, and then came round sort of under the restaurant, took out the whole beach, went onto the road just a little bit, and then took out our lower deck.
We both looked down, and sure enough, the deck is completely gone. It's not just broken.
Coming again! Big one. Back up!
Thousands are caught by surprise.
In any particular earthquake, you'll get a different, what we call tsunami train. There isn't just one wave, there's usually several waves. And it doesn't follow any particular rules. Sometimes the first wave is the biggest one. Sometimes there are maybe 2, 3, or even more relatively small waves, and then you get a huge one in the middle and then some more smaller ones. But normally you do get more than one wave, and they are of different heights, and they arrive over different periods of time, and it can be tens of minutes, even hours, between the first wave and the last wave.
After the first wave, Tom Travers and Richard Anthony are still filming as the second tsunami engulfs their restaurant.
The first wave came through as like a normal wave in the same sort of direction, and then the second wave seemed to go more towards the sort of our northern end and sort of sweep around the whole bay, and it seemed to pick up momentum as it came round.
Almost out of nowhere, it was like a class 4, class 5 rapids just started moving up, like freestanding waves coming right towards us with a bigger wall behind it, and that's when everyone just started screaming, like, run. Couldn't see the road, half the temple was underwater, and just horrendous sounds of crunching and breaking and smashing. It's just horrifying. You're just looking out there going, like, what about the people in town? You know, people are in shops and stores, and it was a really sick feeling, just knowing anybody that would have been on the ground level gone. I mean, just swept away. Hopefully they floated to higher ground or something, but anybody who was in shops would have been in serious trouble.
After the waves pummel Kamala, the water retreats, sucking everything out to sea.
My God, I hope there's no people in there.
Big disaster. Huge disaster here.
When the water was being drawn out with equal force, I mean, there was cars floating by, the fishing boats were all getting smashed into the trees.
Survivors are in total confusion. They've no idea what's caused the waves.
The first one came through, it was big. The second one came through, and no one thought if there was going to be a third or a fourth. And no one just knew at that stage what was going on. Everyone was in panic.
We were being told to get out of here, to get up into the mountain because there could be a bigger one on the way. And after seeing what the second one did, I mean, it had no mercy.
It's 9 a.m. in Sri Lanka, 2 hours since the birth of the waves. British holidaymaker Shenth Ravindra is crammed onto a train with 1,500 others. Like all the passengers, he's unaware that he's minutes from the worst rail disaster in history.
The train was absolutely packed because it was a Buddhist bank holiday, so everyone was going back home to see family and also spending time on the resorts. The atmosphere is very different. You get people walking up and down the train offering to sell you tea, sweets and stuff, and also the trains had loads of children, so a lot of noise and very vivid experience.
The track follows a coastal route from Colombo to Galle. It's never far from the ocean.
The train just stopped, and I was a bit frustrated because I thought, oh God, if we're going to be here for a couple of minutes, I just want to get off this train. I heard a lot of screaming and shouting outside, so I sort of peered outside, and I saw what was mainly women running away from the coast, towards inland, and I didn't really know what was going on. At first I thought it might have been like a game of sorts, and then suddenly I realised why they were running. I heard the water, and it just came like this. I didn't see a wave as such, it just sort of came like a flood. Then all of a sudden it came and started hitting the train, and it hit the train to such an extent that the carriage got detached from the other carriages that were behind us and in front of us, and shunted off the tracks. And then the water started to spill in, felt to come all the way up to my chin, and then I thought, right, I've got to get out of here. I was able to climb through this doorway and make my way onto the corner of the roof and the wall. At that moment in time, there was a lot of chaos and pandemonium and worry and screaming. People were using any escape route that they could. People were passing their children through whatever gaps that they could, and I was helping put these children onto the train.
These photos, taken by Ravindra after the first wave, depict the chaotic scene as the train broke up in the flood.
I didn't have a clue. I just thought it might have been a freak wave, a one-off. I thought it would have just happened along that part of the coast between Ambalangoda and Hikkadur, and it was just a freak tide that came in. People were quite light-hearted about it, thinking, God, that was a bit strange. Lucky we survived. And we're just sort of relaxing and speculating about what happened, and there were kids around me who were hugging me and just comforting them and making sure they were all right, and we thought that there'll be some helicopters or some sort of help would be on its way.
No help is forthcoming. Like thousands along the coast of Sri Lanka and India, the survivors of the first wave are completely unaware that a second, much bigger tsunami is minutes from impact.
It was a sunny day in Sri Lanka that day. When I saw the second wave coming, I don't know whether it's the way my memory's remembering it, but everything became really grey and, dark, and, everything lost its colour. All I could see was a wall of water that took up about 80 to 85% of the horizon, and the sky was blocked. It was limited to about 10 to 15%. I could tell the sort of power of it by the fact that you could see it rippling as it's coming towards us, and you know, the fact that it consumed so much of the houses that were around, you know, gave me a real scale of how big it was. This wave came along, and at this point, you know, there was a lot of children surrounding me. They started clinging onto me and hugging me, and I was losing my balance a little bit on the train. I was expecting that this wave's going to push the carriage to a point where the carriage would just tip over, we'd all fall into the water, and then, you know, whatever would happen would happen. But luckily, it just pushed the carriage quite neatly along to the point where it wedged against the house.
Ravindra jumps from the train onto the roof of the house, one of only a handful who will survive.
My carriage was completely submerged underwater, and the water level was rising quite rapidly. I looked at the other carriage, which was behind us, that was still on the track. That had been tossed around and swiveled completely 90 degrees, and I could see like people still in the train that were obviously dead.
As the train disappeared beneath the water, it killed nearly everyone on board, almost 1,500 people. Throughout India and Sri Lanka, over 45,000 lives were lost. It's 3.5 hours since the earthquake. At the Pacific Tsunami Warning Center, the horror of the disaster is becoming apparent. An internet news report confirms their worst fears. The earthquake has generated a massive tsunami.
We were shocked at the enormity of the casualties. We thought we were still dealing with a magnitude 8.5. We were all wondering, how can an 8.5 produce this kind of damage?
It takes an email from colleagues at Harvard to explain what they're witnessing. The earthquake is now thought to be an 8.9, 4 times bigger than an 8.5.
At that point, things started making sense. Then we started to figure out who can we contact that's ahead of the wave.
No contact points, no organization, no warning systems that I know of in the area. Picking up the phone and thumbing through the phone book or thumbing through the web is useless. In fact, it could be dangerous because you're not concentrating on warning someone who can actually do something for the people. So we're brainstorming, basically. Who can we call?
We then created a tsunami travel time map for the Indian Ocean basin. This gave us an idea of, you know, how much time we had in order to warn people. It told us where the wave was presently, and then immediately we started to try to contact nations that were ahead of the wave.
Just under 4 hours since the earthquake, the Maldives are next on the tsunami's path of destruction. With the wave charging across the ocean at 600 miles per hour, it seems the Pacific Tsunami Warning Center is fighting a losing battle. But Weinstein's travel time map could prove effective. There is still time to get the warning to Africa. Seven hours after the earthquake struck, the east coast of Africa on the far side of the Indian Ocean is next for the tsunami. Using data from their travel time calculations, scientists at the Pacific Tsunami Warning Center are at last able to predict its path.
We contacted our State Department and we advised them that this was a very large earthquake and there was the possibility of tsunami waves striking the east coast of Africa.
The State Department Office of Operations immediately patched us through to the embassies in Madagascar and Mauritius, and we gave them a warning.
Their embassies in East Africa would also contact people in positions of authority to try to get out some sort of warning to the East Africa coast.
In Kenya, there is only one fatality, as news of the tsunami reaches the country with enough notice to evacuate.
I've heard reports that some warning filtered out there, and if we were the genesis of those warnings, that would make us happy.
Over the next 24 hours, The tsunami dissipates as it progresses beyond the Indian Ocean, and disturbances are detected throughout all the oceans of the world. But its wake will resonate for years to come. For most, the tsunami was totally unexpected, but they are all too common in Southeast Asia. One of the worst was in 1883, when the island of Krakatoa blew itself out of the ocean. It was the biggest eruption in recorded history, triggering tsunamis that were catastrophic for Java, Sumatra, and the surrounding islands. Over 36,000 lives were lost. Like Krakatoa, the size of the 2004 earthquake makes it one of the most violent geological events in history. At a magnitude of 9.0, it's the 5th largest ever recorded. The earthquake was so big, it even shifted the Earth.
The force of the earthquake has caused the Earth to wobble.
Richard Gross of NASA's Jet Propulsion Laboratory used seismic data to make some startling calculations.
The earthquake has caused the mass of the Earth to be out of balance, which has caused the Earth to wobble by about 2.5 centimeters. This is just like the tire on your automobile. If your tire is not balanced, it will not spin smoothly.
Not only did the earthquake push the planet off balance, it also shortened the day.
This is just like a spinning ice skater moving her arms closer to her body. As she moves her arms closer, she spins faster. As the mass of the subducting plate moves down closer to the center of the Earth spins a bit faster, making the length of the day a bit shorter by about 3/millionths of a second.
The size of the earthquake shocked us. Probably the largest earthquake in 40 years since any of us have been working in this field, and since the advent of modern seismographs. So we were all shocked, and we were witnessing the largest earthquake on modern record.
But neither Krakatoa nor the Boxing Day earthquake were freak events. In fact, some scientists have been warning of catastrophic geological activity in the region for years. Among them, Phil Cummins of Geoscience Australia.
Started this work a little over a year ago, and our main concern then was the large but not massive tsunami which occur off Java and mainly affect Australia and Indonesia. Subsequently, I sort of tried to look at the wider perspective and what other hazards might be presented in the entire Indian Ocean. And then I realized that these massive earthquakes do occur off Sumatra that are so large that they could cause tsunami that might affect the entire Indian Ocean basin. In 1833, a massive earthquake occurred off Java, and we know that the massive tsunami created by the displaced water wiped out whole villages along the coast of Sumatra. The 1883 eruption of Krakatoa did cause a massive tsunami. The primary area that was affected by that was Indonesia. In 1977, a very large earthquake, magnitude 7.8, occurred just offshore the island of Sumbawa. And this earthquake is responsible for the largest tsunami observation in Australia, which was 6 meters on the northwest Australian coast.
The biggest earthquake for decades, and no way to detect or warn of tsunamis. A network of deep ocean sensors in the Indian Ocean, similar to those in the Pacific, could have saved thousands.
When I first saw the footage of the tsunami inundation, I found it depressing, and I found it frustrating.
There was no sea level data, there were no designated contact points in any of those countries, there was no tsunami education in place. All the critical elements needed for a warning system were missing in the Indian Ocean.
We knew that if this happened in the Pacific Basin, the loss of life is something certainly we could have prevented. It wouldn't have been anything on that scale.
The scale of the disaster has prompted the countries affected to turn to science for answers. But earthquakes are not the only cause of tsunamis.
There are at least 4 causes of tsunami. There are earthquakes which cause tectonic displacement of the sea floor. There are asteroids which are thought to have caused very massive tsunami but are very infrequent. There are also volcanic eruptions which can lead to landslides, and an explosive eruption beneath the seafloor would cause a tsunami. There are also spontaneous landslides, either that occur above the water and insert mass into the water column, or underneath the ocean that change the shape of the ocean floor. But if you're actually going to take concrete steps towards mitigating these kind of hazards, you really have to do some kind of risk analysis and decide where the risk is greatest, and so you can concentrate resources there.
Though tsunamis pose a direct threat to 80% of the world's population, protection against them remains a matter of cost and politics. However, it's not a case of if, but when. In the Canary Islands, for example, scientists fear that one day 120 cubic miles of the Cumbre Vieja volcano could collapse into the sea.
That may generate waves that are 20 meters high all down the eastern coast of the US, 100 meters high in the Canary Islands themselves, and maybe 7 to 10 meters on the south coast of the UK. When they hit the eastern coast of the United States, they're estimated to expend the same energy for every 100 meters of coastline as was generated by the collapse of the Twin Towers. And that's for thousands of kilometers all the way down the east coast.
December 2004 was a stark reminder of the precariousness of our coexistence with nature. In reality, with only 15 minutes to warn and evacuate northern Sumatra, even the most sophisticated warning system may not have been enough to save many of the people who died there. But it would have saved many of the thousands who died in the 11 other countries.
In retrospect, the scientific community should have been aware these massive earthquakes do occur off Sumatra, and probably a little more emphasis should have been focused on the Indian Ocean, where it's documented that massive earthquakes occur.
There's a simple choice. We either make a conscious decision and say, although these catastrophes will happen, they may not happen for 100 years or more, we're going to do nothing about them and we're going to accept the consequences. Or we say, all right, they're very infrequent, but we at least need to plan for them so that when this happens, we can save as many lives as possible.
It's been a heartbreaking thing for all of us in the tsunami mitigation community. On reflection, I'm sure every one of us wishes that we had done something in advance to push a tsunami warning system for the Indian Ocean, and that we could have done something to prepare the region for this terrible tragedy. But we hadn't, and the tragedy had unfolded with its devastating consequences that are going to take years and years and years to recover from, and those families may not ever recover.
Visit our special website to find out more about the power of tsunamis at channel4.com/science, where you can also take part in a web chat right now with oceanographer Dr. Simon Boxall. Next Monday at 9, Body Shock returns. More details of that in a moment.